Hello everybody, welcome back to another Weather Central forecast. Hope you guys are having a fantastic day. Now this is a little bit of a later upload, but I did want to go over the 18Z model run for the severe weather event just because, why not? Obviously there will be more up-to-date forecasts in the near future on this channel regarding this event, but I just thought I'd go ahead and do another update because my video was somewhat earlier into the day than my normal videos. So I do want to start off with a disclaimer that these forecasts are my opinion. They are based off of model guidance and past occurrences of weather. For the most accurate and up-to-date weather, please consult your local National Weather Service office, as they will have more accurate and up-to-date information. I will have, especially on these major events, they'll be going more into depth on those than I will. I hope you guys do enjoy this forecast. So let's go ahead and move our attention over to the models. So here we are here on my updated preliminary look for this system. You guys can see just a little bit has changed with this 18Z model run of the new batch of models, not just one. We're seeing a rain and snow mix starting to develop here. Not as much convective available potential energy throughout these areas up into the north. So we're not really seeing much of a thunderstorm risk extending into parts of Wisconsin, into parts of northern Michigan. We're still seeing, though, a general thunderstorm risk throughout these regions extending into parts of the Midwest, into the Ohio Valley, into parts of, southern Wisconsin, southern Michigan, and into southern Minnesota, extending southward. We'll be seeing those general thunderstorm risks. And then as you make your way into the red, and then obviously as you get your way into the darker purple, you'll see your highest chance of severe weather. As of now, you can see the axis of this has shifted quite a bit, just because, what I believed when I thought that, most of the ingredients needed for this would move more eastward. It did just by a little bit, but it wasn't enough to, keep some of these areas over here into parts of the highest chance for severe weather. It kind of shifted a little more westward than what I was anticipating. So that's a little change there. And we also have some cool conditions starting to develop off into the west coast throughout this system. This is going to be a minor cool down and a very temporary cool down, but it will be cooler than average conditions to what you have been seeing in your past couple of days throughout those areas. So let's go ahead and move over to the models and see what they're saying. So here we are on the weather models. First, we're going to be looking at precipitation. Then we'll go over to convective available potential energy, temperature anomalies throughout this this event. Basically the same things we went over in the last video, just an updated little batch of models throughout these. So we're seeing this low once again. This will be associated with this system. We're also seeing a secondary low up to the north into parts of Canada that will also be contributing to this system as well. So basically this system is going to try to move eastward, and it will, but this system, or this low, is going to be tracking north and east, and it's going to kind of combine with this system throughout the north. It's going to dump some heavy rain throughout these regions and even some snow mixing in throughout these regions right here, like you guys saw in my preliminary outlook to this. And then it's going to cause a squall line of thunderstorms that'll be moving south and east, and eventually, be causing some severe weather throughout these regions. So let's go ahead and move the model on and see if we can see this happen. So we can see this low starting to move north and east. We can see we'll move it back here. Okay, that's my bad. So we're seeing this low start to develop some moisture to the northern end of it, and then this is moving eastward, and these basically, you can already see some of this moisture starting to collide with the moisture from the north and parts north and east of Michigan. We're going to move this on even more, and you'll see it start to, on the southern end of this low, you're going to see another low develop just north of the low that we were just seeing. The southern end of this low is seeing that moisture being combined with these other two lows. We're seeing a third low right here, and this is going to allow for this Gulf moisture to be injected and just kind of be really stationary throughout these regions right here, because once that moisture gets associated with this, it's going to be waiting until these move out of the way, and so that's going to take a little bit of time as well. So we're going to move this on. You'll see that first initial system moves on, and then we'll see this squall line of thunderstorms throughout these regions, and that'll just be moving south and east, causing some severe weather. We'll move this on even more. You'll see kind of a stationary band of precipitation extending from parts of Oklahoma up to the Ohio Valley. we're seeing that higher concentration of precipitation throughout the Ohio Valley into the Tennessee Valley. We'll move this on. We'll see the axis of it kind of shifts into parts of Missouri into Kansas, where we're seeing that higher precip. And then if we move this on even more, you'll see it becomes really stationary. We see some very, very heavy rain into parts of the Oklahoma-Kansas border. That is some similarities that is showing up from last model. It is starting to look like, regions around here are going to be seeing this severe weather, especially on this updated model. We're seeing that similarity, so it's kind of already hinting towards maybe this actually being a real event and something to, really keep an eye out on. It's really stationary throughout these regions. If we move this on, even some very heavy rain into parts of central Oklahoma around Oklahoma City. And then this moves on eastward as night falls. We're seeing that cold front try to dig its way down, and we're seeing this warm air on this, eastern side of the system. And so that's what's going to allow for this to still be rain and still have that chance of becoming severe weather. We're seeing some very, very heavy rain, almost exceeding an inch an hour. If we move this on even more, you can see that just kind of move eastward, and then we're seeing possibly a snowstorm on our hands throughout parts of the Midwest, but that is still a little too far to go out and look at. So let's go ahead and look at our temperature anomalies and see what it is showing for that. So here we are with our temperature anomaly. This is 66 hours out, so this is just right before the system starts. We're seeing some cooler conditions throughout parts of the United States where the severe weather is going to occur, and we're seeing a sharp boundary line between the cooler and warmer air. That's going to cause for some instability, as well as we're seeing this 16-degree below average conditions throughout parts of Kansas. And so once this warm air moves down, this big temperature change is also going to cause some instability throughout the atmosphere. If we move this on, you can see very, very warm conditions throughout these regions right here. And basically, that's also what's going to be causing that stability, because we had such a sharp temperature change. Very, very warm conditions into parts of Nebraska, into parts of Iowa as well. We're seeing some cooler moisture into parts of, the Gulf that'll be injected into the system, as well as that precipitation moves northward throughout the secondary band of this. Some very, very warm conditions as this system is hitting, so that will allow for that severe weather to dig even possibly more north if this trend does continue and does strengthen over the next model runs. We're seeing some cooler air behind it, and this is where, we're seeing that snow mix in on the back end into parts of Kansas right here. We see that temperature change, and that's what's going to allow, like I said, for this stuff over here to still be thunderstorms. It's because you still are seeing well above average conditions. Even if it's at night, you're possibly seeing 50s or 60s. And, maybe some cooler conditions, maybe possibly another severe weather outbreak throughout these regions if we do get that precip to happen, because another sharp temperature change. And this isn't the only way to indicate that, but it is a good indication that if we do get precip, that could change into severe weather. Let's go ahead and look at our CAPE values and see from the updated models what they are showing. So here we are with CAPE. We're seeing this is 75 hours out from the 18Z model run, so 18 hours out from, or 75 hours out from 6 o'clock, so it's probably around 72-ish hours out as this video is being uploaded. So we're seeing some CAPE values into parts of Kansas, into Oklahoma, into Texas. Even in the higher concentration of amount is into parts of southeastern Nebraska. Now this is going to stay under 350 joules, so this isn't going to be enough to spark anything more than an isolated thunderstorm, but you do have some of that risk for, like I said, an isolated thunderstorm throughout these regions. If we move this on even more, we'll see some of that CAPE value still stick into parts of southeastern Nebraska. If we move this on, we'll see a higher concentration of CAPE start to develop into parts of Kansas on this Oklahoma-Kansas border. We're seeing our highest concentration just over 1,000 joules. Our highest concentration, as this model is showing, the max is 1,123 as our CAPE value. So, enough to spark a little bit more than a thunderstorm, so maybe a severe thunderstorm to a very, very low-end EF0 tornado, if that does occur, and we do get those, helicity updrafts in the atmosphere, in that dynamic cooling. If we move this on, a higher concentration becomes likely into parts of Oklahoma, and this will, like I said, that's why my forecast has changed, is because that has stayed fairly consistent as the higher Cape values being concentrated over here rather than farther eastward that was advertised earlier this morning. Just to keep going to see if we're seeing, that move eastward. It's trying to get into Missouri, and it gets into Missouri just a little bit, but it really stays into parts of Texas, Oklahoma, and Kansas, and doesn't really do much. And then, doesn't look like it's going to be a crazy Cape event, so maybe nothing really, really strong, but I do expect as we get closer to this event and a lot more the confidence in the system does increase, I would expect, Cape values to be increasing throughout these areas. And I think that they could even exceed 2,000, just because it is going to be so warm throughout those regions. So let's go ahead and move our attention over to a new filter to see what we could be expecting throughout this system. So we're going to look at shear right now, and then we're going to move over to helicity and see what it is showing for that. So we have some shear into parts of, Kansas into Nebraska. If we move this on, you can see that shear kind of concentrates up into the Midwest, maybe causing some severe thunderstorms, as that does line up with the Cape values. Obviously, this is the same model run, just a different website. And then this really does take off into parts of southern Texas, extending all the way up into parts of into parts of western Missouri. We have that highest concentration around Wichita, Kansas, throughout those areas. If we move this on even more, you can see that shear actually is starting to move eastward a little farther than what the Cape values were showing. So tomorrow's forecast could look a little bit different. Stay up to date, as I will be trying to make, an early morning forecast and a late night forecast, as it will be the weekend and I'll have time to. So I'll probably have 2 updates tomorrow on that. So just stay tuned to those forecasts, and if anything changes, you guys will know. But those highest concentrations of shear is into parts of Texas, extending into parts of Kansas. And then you might see a highest concentration of shear into parts of southern Texas. That could be where some severe thunderstorms start occurring throughout those regions. But nothing crazy. It doesn't look like a shear heavy event either. But like I said, as this confidence does increase, I do expect that to go up a little bit. So let's go ahead and take a look at helicity. So here we are with helicity. As you can see, this kind of lines up with Cape values and the shear as well. You get some strong helicity values into parts of Kansas, into parts of Nebraska. If we move this on even more, you can see that red is some very strong helicity, and that you see those whites, that same indication as the last model, or as that earlier forecast today, some very, very strong updrafts throughout those areas, which will allow for, some possible supercellular development throughout those regions. And that does extend eastward, and it's starting to pick up with model trends. It's starting to move eastward, like I was thinking earlier. So maybe some forecast changes could occur throughout that, as tomorrow, as we get those latest model runs. So that is about it for this forecast, guys. I hope you guys did enjoy. If you guys did, please stay tuned to my, latest updates. I will be making more updates on this system and any system that makes its way through the U.S. So I hope you guys did enjoy this forecast, and I'll see you guys in the next one.